Hi there, welcome back. Chapter 5, Section 2. We're actually on page 5 in your notes. Oh, if you forgot where we were, if you took a break, just go right there and we will pick right up with the baseball question here. Continuing with rates and unit price. 2004, Scott Rowland of the St. Louis Cardinals had 92 strikeouts to 34 home runs. What was his strikeout to home run rate? Right? Well, simply put, you're looking for this key word right here, 2, and that basically tells you which numbers to go first and which number to go second here. All right, the first number is strikeouts, 92 strikeouts, 34 home runs. So you want that 92 to go first, so I put it up here. The strikeouts, 2 is this, home runs is that. So that's your rate right there. If we ask you to go ahead and divide that out, which usually we do, you can say he strikes out about 2.71 times per every one home run that he hits right there. So that's again the bottom of page 5 for you. So the key to this stuff is just really watching this phrasing, particularly in this part of the problem, and making sure you follow it exactly like it's written. If you do that, you shouldn't have any problem there. And then we get into this word unit rate, which really we've been doing that. I mentioned it briefly in the last video. Unit rate is what you do when you find the value per 1, that's what happens when you divide it out. That tells you how many you have per 1. Okay, so if you say dollars per ounce when you divide that out, you're really figuring out how many dollars for every 1 ounce that you found if you're buying some food in the grocery store. All right, or if you're earning a salary, dollars per 1 month, or if you're paying a certain amount of money per month. That's a unit rate when it's per 1. Okay, miles per 1 hour. But we don't actually say per 1. Okay, I just put it in there so you understood that that's what it was. But when you say miles per hour, you're talking about miles per 1 hour, so on and so forth with that. So here's an example. It says, what's the unit rate of a 16-ounce can of baked beans for 99 cents per ounce? Okay, when you find unit rates regarding food like this, you're trying to find out what's the best bargain, what's the best price, the cheapest price for this particular item. And we have to go under the assumption that there are no other variables that we're really considering. It's the same product. Each product is just as good. One is just bigger than the other. Say it's peanut butter. We're going to do a peanut butter example here in a minute, but it's the same brand, it's just different sizes. Okay, you can't throw anything else in when you're just trying to figure out which one is cheaper per 1, in this case, ounce, if you're comparing two. So what you're doing is you're basically finding the cost or the price per whatever the unit is. All right, ounces, pounds, or whatever. So when you do that, you're going to divide the price, okay, divided by the number of ounces. So the price in this particular question is 99 cents. Number of ounces was 16. So you just divide that out. That's your unit rate right there. That's the unit rate. That's the price that you're paying. About, we rounded it off here, by the way, if you didn't notice that, about 6 cents, because that number is less than 5, right? So we can just drop that decimal if we round. You're paying about 6 cents per 1 ounce in this problem of baked beans when you're paying when you're paying, let's see, 16-ounce cans is 99 cents, all right, for 16 ounces. So you're paying 6 cents for 1 ounce. So that's the unit rate there. So with unit rate, what we can do is we can ask ourselves, well, what's the best deal? I mentioned the peanut butter example. I knew this was coming up here. Here you have, let's say that you have 2 different jars of peanut butter. One's 18 ounces, one is 28 ounces. Again, we're assuming it's the same kind of peanut butter. We're not comparing, bad for you peanut butter versus pure organic peanut butter. Bad for you, but you have all these different variables. We're not considering that the spoilage because we wouldn't eat it all. We're just saying which one is cheaper per ounce. Unit rate is how you'd find that. Number 1, 18 ounces for $1.89. So what you're going to do is you're going to do price per divided by ounces, which is 18. All right, price per quantity. All right, now you just divide that out, and you get this 0.105. Now that's like really 10.5 cents. Okay, so it's about 11 cents per ounce. Okay, so let's look at the 28-ounce jar. It's $3.25 for 28 ounces. So we're going to divide 325 divided by 28. That'll tell me how many dollars or how many cents per ounce that you're paying there. And this right here, you see, that's about 11 cents. That number right there is greater than 5, so that we round that up. But you can see right here that the second one there is more expensive. So if you're to say which one is the better deal or the cheaper unit rate, the answer would be number 1, because you're only paying about a little less than 11 cents per ounce in number 1. Not a huge difference to you, but it is a difference. The better deal in this case is the first one. Okay, and then that takes us on to a piece of information that we'll begin here, and then we'll pick up with the next video, proportions. And that is, it looks like we're at the bottom of page 7 in your notes if you weren't sure where we were. And the words to go in the blank here would be proportion. A proportion is 2 equal ratios. Okay, so if we go back to what we talked about in the earlier slides, okay, that is a ratio. Okay. Now, if I set that equal to another ratio, what you have, this whole thing, the whole thing is a proportion. Okay, so a proportion is 2 equal ratios. Proportion is 2 equal ratios. All right, important slide here. Important slide. This slide, where we put the words cross products in the blanks, this slide can solve tons of problems, right? Tons of different problems, this concept here of cross products. All right, a statement is a proportion if, okay, that means it has to be that way, if the cross products are equal. All right, if the cross products are equal. So let's look at this example. All right, 1/2 equals 3/6. Now, I put this really easy one here because we know 1/2 does equal 3/6. We know that's true. So this is a proportion. We know that because they are equal. Okay, but what I'm trying to show you here, and this is really valuable for you to know, this rule of cross products. If you have 2 ratios, remember, ratio, equal. This will be true. The cross products are equal. Look, 2 times 3. That's 2 times 3. That equals 6. Cross products are equal if the same thing happens when I do these two here. 1 times 6 is 6. So yes, these are proportions because these two things are equal. That's what we're trying to tell you here. You need to know that because we can take that and apply it to all kinds of different problems that you'll see here shortly. All right, let's look at a trickier one here that's not quite so obvious. I could throw decimals in there. Not good ways to write fractions, but just to make a point. These are proportional. If I multiply these two things here, and I multiply these two things here, and if those come out equal, that's a proportion. And it does. It does. They both equal 0.768. I think I might have rounded that off. I don't recall. But they did come out to be the same value for you. So that's a proportion. All right. And then I think I have one more to show you, and then we'll stop it, and then we'll show you how we can use this to solve problems. The last one was determine whether 2,5 and 4,7 are proportional. All right, do your math there, crisscross applesauce, and see what happens, and you'll see no. 2 times 7 is not the same as 20. One of those is 14. One of those is 20. So no, these are not proportional here. So that wraps up on the basics. So we're going to take that idea that we just went through, those cross products, and we're going to teach you in the next video how to solve for if one of those values is unknown, but you know it's a proportion. See you soon.